Alright, so let's take a look at this problem number 3. We've got our parent function as the basic sine function. For your reference, I've put the 5 major points here. To determine the period is always 2 pi divided by the coefficient in front of x, which is pi. Reduce this so my period has a length of 2. The amplitude is always the multiplier in front of the sine or cosine. That's 1. The center line is always what you add or subtract if you lift this graph up or down. We have not done that. The center line is always an equation, and in this case it's y equals 0. So this pi is actually a horizontal shrink, so we're going to have more than two places where it crosses the center line. So let's list them between 0 and 2 pi. Our first one is at 0. So if we replace pi times x with 0, that just means that at x equals 0, we know that if you plug in 0 into this, the sine of 0 is 0. You're on the center line. If we allow this pi over x, pi times x, to equal pi, if we replace pi times x with pi, x is equal to 1. So I know now that each interval of 1, you're going to be on the center line. So if I want to be between 0 and 2 pi is about 6.13. So x equals 1, 2, 3, 4, 5, 6. On the 7th one, I'm beyond 6.28. So I've got 7 places here on 0 to 2 pi that this curve is going to intersect, it is going to cross its center line. All of these are x-intercepts in this case because the y equals 0 is the x-axis. Now, to figure out where to write this in general, in a generalized form, to describe infinitely many of these, we just take the x equals 0 and we add half of the period, so we're just adding 1 times n, and there we have it, because n is any integer. So replace n with 0, 1, 2, 3, 4, and you'll generate that list. Hope that helps. Talk to you later.